So thank you everyone for coming, and thank you very much, Luc, also to be our first guest, because indeed this meetup is the first one of the alumni club of San Francisco from the Sorbonne University, and then we'll have a conversation about AI. So if you need the Wi-Fi, you have the password over here, and if you're kind enough, you can also follow us on Twitter, and you can tweet about this meetup with the hashtag SorbonneSF. So before we did dive in the core contents of this meetup, let me say a word about Sorbonne University for the ones who may not know yet this great institution. So the roots of the Sorbonne University coming back from the 13th century. This is the 5th oldest university still running in the world. And there are more like 32 Nobel Prizes, field medals winners. So great institutions, but it has been also reshaped. But the core of Sorbonne University is multidisciplinarity. I know Luc also is something that you like a lot, like being multidisciplinary. Research intensive, also something you're familiar with. And also, devoted to meet the scientific challenge of the 21st century. So yes, it's an old institution, but yes, towards the future. And the specificity of this university is really the focus on science and humanities. In Paris, there's a lot of universities actually, this is the best one in France for science and humanities. Myself, I did study in philosophy and in communication at the Sorbonne University, Luc obviously is studying in science. And also, related to the topic of the day about AI, Sorbonne created the Sorbonne Center for Artificial Intelligence with 4 priorities. Obviously math, computer science, robotics, but also medicines. And maybe less anticipated for general audience, climate, universe, and environment in general. And the 4th one, which is also close to my heart, about digital humanities. Because yes, artificial intelligence could maybe save the planet, maybe save our life, and can also reinvent the jobs of today. Maybe also it can be better to understand us ourselves as a species or about the culture. And so about this alumni club, so we are official, it's just not my personal initiative. So Sorbonne University recognized that the main asset of any educational organization is the alumni. When you have alumni like Luc Julia, for instance, it's great to make your university shine because maybe you're more famous than the university in the US. So I was even surprised myself, but there are more like 3,000 Sorbonne University in the Bay Area itself. So we hold high. We are not so common to find. And indeed, yes, if you are a Sorbonne alumnus, or if you know one, invite them to join our LinkedIn group. It would be the main platform for us to connect. And then we'll share meetups like that, but also more private meetups where we just meet between alumni. And the objective of this club is to be a bridge between Silicon Valley and Sorbonne University. For instance, the Sorbonne University executive, especially about the AI, will come in January to connect with also local researchers, local experts. And if we as a network of alumni we can help, that is also great for alma mater. And we have these types of meetup, but I wanted to have a focus on science and humanities, because it's true that most of the people who come to the Bay Area, they either come from like engineering school or business schools. So we are coming from like a public university focused on deep science and humanities. We were kind of troublemakers, and we also have common points to talk about. And yes, we want to cultivate our difference, and we also want to cultivate these values of science and humanities. So the agenda of the day, so we're gonna talk first about Luc Julia and his work, so you can better understand where he's talking from. Then yes, we'll talk about origins of AI. Then we'll ask him to debunk the myth about artificial intelligence, which is most of the topic of his book that has been released last year. This year? Oh wow, it was not so far ago. In France and soon in the US. You'll tell us about that. And then yes, we'll talk a little bit about the future of AI and also about the topic of AI and sustainability. And then it will be open for questions for all. And after that, we could have some wine and cheese to have a more casual conversation. So let's start about the core content. So instead of reminding you on only a 4 letters word, I thought it would be funnier to talk about Luc Julia about different aspects. So he created his first robot at 9 years old to just make his bed. And he was making his mother very happy. And he created, his first company he created as an entrepreneur was audio guide tools for Walkman about San Francisco. So yeah, we would love to listen to that. He created the first prototype of Google Maps before Google was even created. He created the first connected switch back in the 90s. The first AR prototype mixing online search results and car navigation, also in the 90s. And also the capacity to watch some live TV content directly on the phone. Nokia, I don't think it was a Nokia 33, but I don't know you did that on Pixels, but yeah, he did that way before the iPhone was even launched. So you could think of him like maybe a crazy inventor on his side, but not only is a great inventor, but also he had a great impact. So also very diverse career, 10 years as academic, 10 years as a startup entrepreneur, and for the last 10 years as with tech giants, like today with Samsung. And he did about impact. He joined HP, connected the printers that we all know today, so impacting more than 80 million customers. Then obviously you all know about it. He contributed to the core technology that gave birth to Siri, impacting like 300 million peoples. And today also with Samsung IoT, more than 1 billion people can be impacted by Luc's works. And yes, also fun facts. So in his book, it was written that you had 209 connected devices, but you told me just before that this number has been updated, right? 2012, okay. So think if you have 200, there. 200. Think if you have 212 connected devices in your home, and I was asking, but if you have 50 Windows, yes, the 50 Windows, they say no, 212 different types of connected devices. Okay, it's just not 50 light bulbs. I don't even know if I have 212 items in my home, but so it's about the connection. But yes, that's the little foundation. And you may think, and that will be my first question, how can you do all these things? You know, how one person can do so much things? And in the book, you talk about one figure, this one. So I wanted to ask you and to explain to the audience what this figure means.
Yeah, so it's bad and good. So the bad part is that it relates to the death of my father when I was 11 years old. So he died, right? So and I was at the burial, right? So and I see on the grave 2 dates, the dates of his, his dates, so birth and death, and I see the one of my grandfather that I never known, and it was, kind of similar dates, and I did a quick calculation, and I realized that it was exactly for both of them 17,469 days. And so, of course, 11-year-old, I was sure that my term would be at 17,469 days as well. So I calculated, rapidly as well. And I knew that I had only about, 30 years to live. So I said, okay, I need to do stuff now. So I did accelerate a little bit. So yes, I did some robots before, but I said, I really, time is very, very short now. So let's move.
Yeah. So after that, yeah, he made you study also, and you did also work at the CNRS, right? So mostly academics at the beginning of your career, right?
Yeah, so my goal, since I was actually 5-year-old, I wanted to be a chercheur au CNRS, which is a researcher, at the French research institution. So don't ask me why, I knew CNRS when I was 5. I have no idea, and most likely because my parents, were in the were teachers, and so they knew the stuff, and they talked about this thing. And so, since I was 5, I wanted to be, researcher at the CNRS, and I did everything because I was kind of in a hurry. I did everything I could to go to the CNRS, and 10 years after the death of my father, I was at the CNRS in the lab, working on computer science stuff, and so I achieved my goal, but I decided to leave after about a month or two. Because it wasn't at all what I was expecting. I don't know if you want me to continue or...
Yeah, I think it was interesting to... you were excited by other research works and you wanted to collaborate?
Yeah, exactly. So, and again, I'm talking about the CNRS about 30 years ago, so I don't want to know, I don't know to say that it's the same thing today, right? So I have no idea. But at the time, when I arrived at the... in the lab, that was the URA 820 at Telecom Paris. My boss, who was my director, she said, okay, now you know that you are here, you cannot collaborate anymore with the people in Grenoble, because if, by any chance they are doing something better than we do, they are going to get more money than we do. So of course, it wasn't exactly my vision, let's say, of research at the time. And I was a little bit upset because my ideal, the thing that I wanted to do for 20 years, did disappear basically in one sentence. And I was lucky enough to be able to leave right away. And I left for MIT and after San Francisco, Stanford. So that's the story.
Yeah, so it's great. So. And then you moved to indeed Silicon Valley, and did you find the collaboration mindset that you were looking for in Silicon Valley?
Yeah, so when I arrived here, it was more than 25 years ago. I did not expect much. First of all, I was this guy from Toulouse, and a little bit. I didn't speak English very well. I still don't speak very well, but. I didn't like the States as a principle. I was kind of, not comfortable with the policies, let's say. And so, but when I arrived here in the Silicon Valley, the very first week, my new friend, Adam Chaya at the time, who is the guy who did Siri with me, so Adam Chaya told me, okay, you should go to this place that is at Xerox Park every second Tuesday of the month, that is called BECAI. And BECAI means Bay, like Bay Area, and CAI, computer-human interaction. Computer-human interaction is what I was specialist of. This was what my PhD was about. And so he told me, go there, it's going to be interesting most likely because, it's your subject, so you're going to love it. So I went there, and of course, if you are doing any kind of computer science and it's kind of, something around computers, and Xerox Park is the place that gives you goosebumps. So because this is where everything was invented, basically, in terms of computer science. And so when you arrive in this place, and this is an ugly place, first of all. This is in Palo Alto, this is very ugly, building from the 70s, it's pretty bad. But you enter the amphitheater, you know, and you have maybe, I don't know, 200 seats or whatever it is. And there, you know, you have all those guys that are here, that are there. And I did talk about them in my PhD thesis, you know, every single of them. And they were all talking, you know, and they were all those guys 50, 60-year-old, you know, and they were the icons for me, right? So, and they were all talking together, and all from different companies. Some were from IBM, the other one from Xerox, the other one from Microsoft, whatever, you know, a lot of companies. And they were all like kids, you know, and exchanging and you know, doing a lot of very interesting conversation. And I entered this building and I said, shit, I mean, you know, those guys, they are all from different companies that are fighting, you know, for billions and stuff. And me, I couldn't talk to my friend Arnaud Gourdol from Grenoble when it was, you know, from CNRS. It was the same company, and I can't even talk to this guy. And when I see here, you know, those guys collaborating like that. And this spirit, this collaboration spirit, you know, that I found that very day, I mean, I still feel it today. I mean, it's still there. And for me, when I look at the Silicon Valley, I mean, it's the spirit of the 1849. So, of course, you know what 1849 is. Here in San Francisco, this is, you know, the 49ers. So this is the gold rush, right? And this gold rush was all about a lot of different, I mean, people from multiple cultures. People, you know, very, very different that are just all driving for one goal. At the time, it was gold. But, you know, today it's the same thing. It's still the spirit of this multicultural, you know, aspect of the people that are just, you know, joining to find something interesting in this valley. So I love this melting pot. This is really the melting pot of the States. This is what the States are about, actually. And I learned that, you know, years after years. And then, you know, now, I mean, even when I reflect back, you know, on all those years, I mean, this is what I really, really appreciate in this area, is that we don't care about the colors, we don't care if people are blue, black, you know, yellow or whatever, we don't care. And we just, you know, all work together, and this is, we all bring something that is, you know, from our cultures, from where we are coming from and from our view of the world. So this is really what I enjoy here, and this is what, you know, this Bekai thing, you know, taught me over the years.
That's great. So good things can happen in meetups. You're smart to attend. Yeah. So to prepare this meetup, you gave an interview to Joanna to French Morning, and she entitled from your conversation this quote of yours, saying that you're a bit fed up that people talk to you about Siri. So I had to cancel my reminder to Siri to talk to you about Siri. But jokes aside, what I love also in your book is that you explain that the success of Siri is thanks to the introduction of artificial stupidity. And you also talk about the nightclub paradigm. Maybe you can explain to the audience what is the nightclub paradigm.
Yeah, so I mean, we're going to talk more about AI most likely after that, but I mean, basically this is one of the aspects that we don't understand, I think, still, you know, when we talk about AI. I mean, AI is always right. We can discuss that, but you know, let's say robots or machines that we are building, they're always right. They're always doing the things, you know, correctly, the way you taught them to do it, right? So, for instance, you know, if you come back, I don't know if we're going to talk about Pascal at one point, yes. Yeah. So if you you know, look at all the machines, they are going to do the right thing. Us humans, we don't. And so what we realized, you know, when we were doing Siri back in 1997, is that the machine actually in this particular case was wrong a lot of the time. But the scientists wanted it to be right. So they thought they were claiming that speech recognition was working, where we knew very well that speech recognition wasn't working. And so maybe the mistake that we did, and I'm going to explain why I say that now, the mistake that we did is that we brought some humanity to Siri to the speech recognizer in order to explain why it was making mistakes. And the best way we explained it was making mistakes was to imitate humans. And to imitate humans, we added what I call the artificial stupidity, which is actually based on this famous now paradigm of the nightclub. So, what's the paradigm of the nightclub? The paradigm of the nightclub is, you're in a nightclub. There is a lot of noise, right? Boom, 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 boom. Noise, noise, noise. You're a little bit drunk, you know, nightclub, right? I mean, this is what it's supposed to be. So, boom, 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 drunk, 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 right? And then, you know, there is a person that you like that is coming to you, you know, and, you know, he's starting a conversation, you know. And you don't want to look stupid because, I mean, you are smart, right? I mean, and so you are looking at this person, you know, and this person is talking to you, but you get 50% of what he's saying, right? I mean, because you are drunk and there is noise. So, but, you know, he's very engaged, you know, and he looks good, I mean, you know. So you want, and after a while, this guy, you know, obviously he wants an answer from you, but you have no fucking idea what he's talking about. But so you do. So this is, you know, a little bit stupid, right? But still, so the guy is encouraged, right? So he continues the conversation, and then, you know, after a while, you feel that really he needs something for you, but you really don't know what to say. So you talk about something else. Right, so I mean, he's talking about Y, and you talk about Z, and he's okay because he's drunk as well. So that's fine. So, but at the end of the day, I mean, this is what the paradigm is. I mean, when we don't know what we are talking about something else. This is actually what made the success of Siri. Is that Siri, you know, when it didn't understand, which, you know, didn't understand about 30% of the time, then, you know, it was giving you a joke or it was giving you something else. And this is what made the success of it, because we knew it wasn't working. Well, the other guys that were very proud of themselves, you know, they were saying, our thing works, you know, we don't need to do anything, you know, else because it's working. Well, it sucks, right? And it still sucks, by the way. But
no, it's a good story, I think, yeah. It's a good introduction. You have a lot of questions for you, but now I'll have a question for the audience. Does anyone know what is this? If you have an idea, you can raise your hand. You can cheat.
Cheater.
Yeah. No one? So, this is what we call in French the Pascaline. And this is the first Blaise Pascal calculator. And yeah, you remind in the book that yes, it was the world's first computers, kind of. And so yes, it's a French invention, so we can be proud of that.
It's more than the French thing. I mean, it's the first one, and it's not easy. I mean, actually, when you think about it, it's very easy. 1642, right? Yeah. 1642. It's pretty cool. And when you look at it, I mean, this one is 6 digits, so it does just addition and subtractions, right? Pretty easy, but it's not that easy. But think about it; it's easy. It's just wheels, you know. And when the wheel, you know, go to you have the thing that goes up. So pretty simple, but it was pretty cool. And you know what? This thing never make any mistake. Never. It's always right. 239 plus 1052. Okay. So you don't have it. If you had it, you know, half of you would be wrong, right? This thing has it in about 3 seconds. Oh yes, it's slow, but you know, 3 seconds and it's always right. That's not our intelligence. That's artificial intelligence, always right.
But yeah, the spirit about that is that even Siri or even sophisticated software, they just follow the same logic, that sequence of rules and just mechanism that activated them.
Yeah, it's based on mathematics at the end, so we can talk about the differences, you know, between rules and statistical method. This one is not statistical. This one is purely rules. Yeah. But I mean, this is basically what it is. I mean, what we call artificial intelligence today, it's still only mathematics. Testing 1, 2.
So yeah, to talk about specifically about the term of artificial intelligence, you explained that yes, the first usage of this term was during the Dartmouth summer workshop with these guys in the background They have very ambitious program. You explain in the book, yeah, maybe you explain it more than better than me. So I'll let you explain how foundational was this workshop and the consequences of it. Yeah.
I mean, it was the first time the term artificial intelligence was used. So it was in summer of 1956. And 1956 was much after 1642, right? So for me, it's not the beginning, the actual beginning of artificial intelligence, but this is one of the time. This is the time where it was introduced. So as a term. But the issue that they had, those guys, is that they decided that it was applicable to a neuron. They had basically a mathematical model of a neuron, and they said, okay, I had this neuron, so it's not a neuron that we know today. It's a neuron from 1956. So very simple, some things some parameters that I can apply, at the entrance, and then I get some results. So simple neurons. But the issue that I have with them, is that they said, okay, I have a neuron. I can create a neural network. Neural network, very good. And then I have a neural network. I have a brain. If I have a brain, I have intelligence. So I just created artificial intelligence because, through this mathematical modeling of neuron, I can now, decide that I have a brain and I have artificial intelligence. So that was the main mistake. In addition to that, they said in 1956, they said, okay, we are going to tackle a problem that is natural language understanding. Natural language understanding is certainly the most difficult thing that we can, do. And as Descartes said, the language is, from humans, only from humans, right? And this is something that is very, very difficult. We don't understand why we understand it. And so they said, okay, we are going to tackle this problem of natural language with these new neural networks, this new, artificial intelligence. And that's, where it didn't take long for them to realize that it didn't work. So after 4 years, it actually, fell apart. And artificial intelligence started what we called at the time the winter of artificial intelligence. And there have been many since then. But this is, one of the reasons when you lie, maybe not on purpose, but when you lie about something, or when you give too much expectation about something, it can be, having some consequences. Because here, in this case, the domain was dead in the early 60s, which is pretty bad. Something else replaced it, but I don't know if we're going to talk about that.
Yeah. So there was a lot of hype, and then with the AI happened, but today there's a popular myth is that artificial intelligence is becoming so powerful that it will take our place, it will destroy our jobs, and then it will kill us. So there's 3 components in this myth, like, is AI actually intelligent? Can it actually replace us, and can it be autonomous? I think maybe we can jump directly on your definition of intelligence, right?
Actually, I don't have a definition of intelligence, but I don't know what intelligence is. I mean, first of all, I don't know what the brain is. And I'm not the only one. I mean, even the people who are studying the brain for years and years, they are saying that they know about between 20 and 40% of the brain, right? So how can you model something that you don't know? So first of all, it's complicated. And how can you model something that gets out of this thing that you don't know what it is doing, right? So intelligence, I don't know what it is, but if I had to give a definition, I would say that it's about creating something that didn't exist. So innovation is intelligence. Inventing something is intelligence. Creating something is intelligent. You're going to tell me, okay, there are a lot of machines that are creating and stuff. Oh, we can talk about that because they are not creating anything, I can tell you. But intelligence is something that we cannot really define. What I'm sure about is that artificial intelligence has nothing to do with intelligence. And for that, I have many, many examples that I can talk about now or later.
You can talk, yeah.
Now, okay. So I'm going to take 2 examples. 3 examples. First one is in 1997, there was a machine that did beat Kasparov at chess, right? So it was called Deep Blue, done by IBM. And it was very impressive, right? I mean, Kasparov, he was world champion of chess. I mean, chess is a very difficult game. You know, you need to be intelligent to play chess, right? So, wow, the machine was now more intelligent than people, right? No, it has nothing to do with intelligence. I mean, when I'm talking about the mathematical modeling, you know, of the whole things, in this particular case, because the neural networks were not, you know, on hype anymore because of the failure of the 60s, after that there was something else that came on. It was the system experts, right? The expert systems. So the expert systems, they are basically a bunch of rules, and you know, so this is the way we were programming, you know, until a few months ago, right? So basically, if then. So this is, you know, a bunch of rules, and this is what the expert systems is. And in 1997, for the very first time, it was possible to have in memory every single move of chess. Chess is a well-known game with rules, and the number of moves is about 10 to the power of 50. Okay, this is what the mathematicians are saying. You know, so 10 to the power of 50, and for the first time we were able to put in a memory all the moves, and basically Kasparov, you know, was very good, can see about 20, you know, moves. I can see about 2, and the machine could see all of them. So it was an advantage, you know, that was there, and after that you need an algorithm to find, you know, the right path. But basically, you know, it was a combination of processing power plus memory, but it was just memory. You know, and it was just applying rules, so it wasn't at all anything related to artificial intelligence, to intelligence, I would say. It was artificial intelligence, but it was expert systems. So that was, you know, there, and we started to say, okay, this is intelligence, but again, nothing to do with that. Now there is 2017 or 16, I don't remember. It was Go. So this time, you know, the world champion of Go was beaten, you know, by a machine, and DeepMind is the name of the machine, and the program was AlphaGo. And then people said, okay, this time, you know, the machine is really much more intelligent than the human, because Go is not actually a finite game. This is something that you can calculate the number of moves. You know, it's a very complex game, and mathematicians, when you talk about Go and you ask them, you know, how many moves that in Go, they are saying it's between 10 to the power of 172 and 10 to the power of 752. So what I just told you is that they have no fucking idea what they are talking about, and so we don't know. We just don't know how many. But what is sure is that, you know, even if we say that it's 10 to the power of 200, 10 to the power of 200 is much more than 4 times 10 to the power of 50, right? So because some people, they believe that 10 to the power of 200 is 4 times 10 to the power of 50. We agree that it's not that, right? So anyway, and 10 to the power of 200. I mean, there is no way you can put everything, you know, in a memory. There is no memory ever that is built that has this kind of capacity. So in this case, what was interesting is that, you know, 2017, 16, neural networks came back after, you know, the expert systems. So neural networks is what? Neural networks is about it's a statistical thing. So you give, you know, samples, and it's going to statistically to try to find something that is similar in order to retrieve in a large database, you know, whatever it is. So anyway, bottom line, there, it was an application of a rule, because there is a rule at Go, and application of machine learning, deep learning at the time, okay? But when you look at the machine, you realize that, again, it has nothing to do with intelligence. And why do I say that? Because when you look at DeepMind, the actual machine, the machine had 1,500 CPUs. CPUs are the, you know, processing units that are in the computer. So 1,500 CPUs, about 300 GPUs. GPUs is another kind of processing units, but this time this is for matricial calculation, because it's for displaying on the screen, and it's very convenient for calculating, in statistical methods. So anyway, and there were something else. There were about 30 TPUs. TPUs is a very specific processing unit that is done by Google, that is specialized in TensorFlow. TensorFlow is one of the frameworks that you can use in neural networks. So anyway, so you had in this machine, you had about 2,000 processors, right? 2,000 processors. If you made a calculation of this small data center, this is what it is. This is a small data center. This is 440 kilowatt an hour. 440 kilowatt an hour to play Go. Okay? Now you look at the guy in front of the board, in the other side of the board, the world champion. He had just that. Do you know what it is? Do you have any idea what do we develop in terms of power in our brain? 20 watts. 20 watts. And hopefully this guy can do something else than just play Go, right? So 20 watts to play Go and do a lot of stuff against a machine that can only play Go. Yes, it's very good, very, very good. But only play Go, 440 kilowatt an hour. I mean, this is ridiculous. So it has nothing to do with our intelligence. It has nothing to do with the way our brain works. So that's another example of that. So we need to keep in mind that, and we can talk later about some of the issues of artificial intelligence, but this power that is consumed just to do some very specific things might not be exactly the right way to go. Another example is the autonomous driving. A lot of people are talking about autonomous driving, and that cars are going to drive very soon by themselves, and they are going to handle any situation. This is called level 5 of autonomous driving. Today, with Tesla and stuff, we are around level 2, level 2.5, right? So people say level 5, they will be able to handle everything. So I tell you today, and this is something that you can discuss, or you can go to evangelize that. I tell you today, level 5 will never exist. Never. Just can't. We are level 5, right? So we can handle any situation. And we are going to be pretty good at it. I mean, sometimes we are going to have accidents, but we are pretty good at handling, every single situation. What I'm telling you is that level 5 will never exist, because whatever robot, whatever machine, whatever thing that you are creating, it will never be able to handle any situation, especially any new situation. And for that, you don't have to go very, very far. For the French people in the room, you can go to Place de l'Étoile at 6 p.m. at night. Okay? Place de l'Étoile, 6 p.m. at night. I mean, if you did experiment it, it's basically a roundabout with about 12 streets, coming in this thing. And this is a big mess, of course. I mean, and there are plenty, if you look on the internet, there is a very well-known crossing in Kinshasa that is very interesting as well. So plenty of situations. But when you are there, you realize that it has nothing to do with the rules of driving. You don't apply the rule when you are on this roundabout. This is something else. This is sociology. This is, negotiating power with the guy next door, in order to try to go through. I mean, it has nothing to do with the rules. It has nothing to do also with a previous situation. Every situation is unique. So it's going to be very interesting to see that. And today, obviously, if you put a car, an autonomous car level 2 or 3 of today, in this thing, I mean, it doesn't move. It won't move an inch. Okay, until it's midnight, where there is space. But this is another example of the fact that artificial intelligence is very different from us. I mean, we would be creative in this case, where the car is not creative. The car is going to be programmed, basically, with data that has been seen before. Okay, and you can add some rules, of course, at any time, and you can, have a better system. But as you know, I mean, there is always a situation that won't be expected. And one last one that I love, it's still in autonomous driving, You know Waymo, right? Waymo is this company, the Google company that is doing autonomous driving. They are most likely the most advanced company in autonomous driving today. They did drive 11 million miles today with their autonomous cars, with always somebody behind the wheel. And recently, they did release the videos of those 11 million miles. So for fun, you can go to YouTube and you can go to watch the 11 million miles driven. I don't recommend it, it's pretty boring, but I do sometimes because I'm pretty silly, right? So, and one day I found the best video ever. So, it's not in the book, it's a scope. So you see, so the camera is just behind the wheel, right, behind the windshield, right, so it's right there. And so you see the boring, thing driving in Palo Alto or Mountain View, right, on the street that has no interest at all. And so you are there driving. And so this video, you see the thing and the car stops. In the middle of nothing, no stop, no light, nothing, it stops. And then 2 seconds later, starts again and stops. And 2 seconds later, starts again and stops. And then you feel that the guy that was behind the wheel, he took back the control and drove because the guys behind, they were a little bit nervous, I'm sure. And I said, but what happened? It's incredible. And then the video are not very, very good quality, but you can zoom, and I have the screen capture. You can zoom on the video, and then you see on the sidewalk 2 guys walking. Okay, 2 guys walking, it doesn't matter. And then you zoom a little bit more, and you see that the 2 guys walking, one of them has a stop sign on his shoulder. And I say, shit. And the car, stopped every 2 meters because it saw a stop sign every 2 meters, right? You, as a human, if you see a fucker on the side of the road with a stop sign, you don't stop. I hope so. If you do stop, we need to talk as well. Huh? But I mean, of course, today most likely there is a line of code somewhere that says if there is a jerk with a stop sign on the sidewalk, then don't stop. But I mean, this is ridiculous, right? So bottom line, it's not the way it works that way. But I mean, we cannot have every single case, in the database or in the training database. So this is one of the issues.
Yeah, so it's a great recap to challenge artificial intelligence about intelligence, and I really love your definition about curiosity, creativity, invention, innovation. And that's why you suggest that, yes, maybe we can keep AI as an acronym, but we can more talk about augmented intelligence.
Yeah, so I mean, of course we need to keep the acronym because, I mean, it's there, it's easy. And I have several of them, I mean, of course, I'm using augmented intelligence, but it's maybe not the right one. Right now I'm using also a lot advanced innovation, right? Because this is I have an AI lab in Paris, so I need to call it the AI lab, so it's an advanced innovation lab. So anyway, but here the augmented intelligence idea is that it's actually not the domain itself that is the augmented intelligence. It's the tool that is the artificial intelligence that is augmenting you as a human being. This is just a tool. Like every single tool is going to augment you, it's going to allow you to do more things than what you were doing before without this tool. And this is the way we need to see this thing. I mean, whatever it's doing for you, it's doing it for you, and you decide. Like every other tool, you can decide to use it, the bad way, but you can also use it the good way. This is what we're hoping, of course, when we are creating a tool. But think, 300,000 years, ago, when the first guy, invented the knife. He invented the knife to kill the mammoth, right? So great. But one day he decided, to kill the guy next door. It wasn't good, right? So a tool can always be used, in the wrong way. But this is where you need regulation, and this is where you need, ethics and all those things. But we can also talk about that more later.
Yeah. So I think another topic, like specific question, is that will AI will destroy the net destruction of jobs?
Yes, of course. And by the way, not only AI, every tool. So like we were talking about tools right now, every single tool in history did destroy some jobs. So I'm just going to give one example in France again, in 1770. 1770, it was the very first time there were some robots doing the, I don't know how to say that in English, les machines à tisser. Somebody knows? It's not à coudre, it's à tisser. In Lyon, des canuts, they had some very, they were replaced basically by the machine. There is a machine that is well known, that is machine Jacquard, that by the way, it's known, but it's not the first one. Jacquard was 1801. But anyway, so those machines, they replaced the canut. They replaced the guys, that were doing the very fastidious job of doing, that. I don't know what it is again. But anyway, and there was a revolution. I mean, people were not happy, and there was the famous Révolution des canuts, which is, something that happened in Lyon in the early 19th century. But when you look at history, you realize that a few years later, and those years are going to be very long for the people that are going to be replaced, but the reality is that in this particular area, in this particular domain of, doing that, there were some new jobs that were being created in order to take care of the machines and to do, to prepare the machine to do something else. Another example that I found very interesting and that has been done by an economist, an American economist, the work has been done by an American economist, it's studying what happened with the ATM machines. Back in 1990, they were the first ATMs, right? So, and people said, okay, it's going to replace all the bank tellers, right? You say
teller.
Yeah, the guys behind the desk, right? So it's going to replace them. Great. I mean, it's going to be a revolution again, right? So it's going to be bad for those people. And then, the study shows that it took about 10 years to have the ATMs in every single banks, basically, in the States, or in France, or any country. And then the study also shows that a few years later, so 2010, there were actually more tellers in the banks than what it was in 90. So instead of destroying the jobs of those guys, it was steady, it was not, I don't know, this thing is, well, weird. So anyway, it was kind of, flat, but it was still, going up. So it was 1 or 2% more than what it was, at the time, but it was not the drop that was expected.
Let me try this one.
It wasn't the drop that was expected at the time, that basically no more bank tellers. Why? Because like everything else, people are, we are humans resilient. So we are going to make everything in our, capacity to invent ourselves and reinvent ourselves. When you look now and when you talk to the bank tellers today, they are going to tell you, I love my job much more than what I was, liking it before, when I had to give just notes, to people. Now I'm actually, also an insurance advisor. I'm also, doing some credit stuff and stuff like that. So what happened there, is that the bank itself, the job in the bank did change over the course of those years. And so the job was reinvented, and actually, it did create some job. The last part about this thing, and again, as I said earlier, I'm more on the left spectrum than on the right spectrum, but we did in France, a big mistake in the 80s. In the 80s, it was in 1981, it was when Mitterrand was elected. And there was a choice that was made not to put any robots in the factories of the north and east of France. Okay, it was a choice because it was going to destroy the jobs, right? And we wanted to keep our industry at the time, right? And it was an old industry, but we wanted to keep it. Remember, in the 60s, we did replace with robots, in the auto factories. But anyway, so at that time, 1981, it was a conscious decision not to do that. In the other side of the border, in Germany, they did put robots everywhere. Okay, and they did kill a lot of jobs. It did last for about 10 years, where jobs went down. It was bad. But now, let's look, 30 years later. In France, north and east, no more industry, zero. Not only we didn't keep, the jobs, but we lost because of the lack of competitivity. We actually lost, our industry altogether, all gone. The other side of the border, this is Germany. I mean, competitivity went up. They kept their industry, and their unemployment rate is half of the one that we have in France. Okay? So, and when you look at Japan, for instance, which is the most robotized country in the world, this is also one of with the least unemployment. Okay? So we need to be careful too when we say, okay, we are going to lose jobs. Yes, but we are going to create new jobs. There are a lot of studies that are showing that in 2025, which is very, very soon, maybe 50% of the jobs will be new jobs that we don't even know what they are today.
So the related question, you started to mention something related, is that is the robot tax, is taxing robots a good idea? Even Bill Gates thought about that.
Stupid. This is very stupid. So, we can always invent new taxes. That's fine. But in this case, this is not what is going to change anything. Again, we are going to keep and to have some new jobs, and we are going to keep us entertained. Let's say. Okay, so we are going to be able to do stuff, and maybe it will be less intense, but maybe it will be less hours or something. But it will be for our good at the end of the day. So. Robot taxes, we know a lot of people that are talking about it. I don't see the reason for it. I'm not an economist. I don't know, much about this thing, but I don't understand why we would do that. When it's going to help people at the end of the day. It's going to replace some of the robots that we are talking about. And since, the 60s, they are actually taking the tasks that people don't want to do. Right? So if you are talking about robots that are going to be to replace accountants, lawyers, and jobs that are more in the white collar area, maybe, and most likely yes, it will happen. But it's going to give the opportunity to those guys to do something that is more interesting. This is what I really, really believe. So there is no reason to tax the thing that is going to help us to do something more interesting.
So related to that, to this against this myth that yes, AI is actually intelligence, it will take our jobs, and it will even kill us. I think I was wondering when I was reading your book why AI experts write a book called Untitled. There's no such thing as AI, and I understood that when you explain in your book that the previous hypes, like you explained after the Dartmouth workshop, the expectations, the high expectation we had about AI led to winter AI winter, where there's lots of less funding about the AI research. So do you think with people like Elon Musk saying that yes, the robots are going to actually kill us, that they're going to return their tools against us, you think this type of myth of threats could also lead to AI winter in terms of the actual research?
Okay, so right now AI is in every single mouth, and everybody is doing AI. So it's going to be difficult to really kill it, and to enter winter right away, right? Because everybody again is doing AI. But I believe that if we continue this, kind of speech about the fact that robots are much more intelligent than we are, they are going to replace us, it's going to be the apocalypse, and we are going to implant, stuff to augment ourselves. This is only the other kind of augmented intelligence that he's talking about. I think it's wrong, first of all, because it has no scientific, basis on that. But yeah, it might possibly, make things bad for the research where AI, the way we define it today, which is machine learning and deep learning and expert systems, has a lot to do to give us still. I mean, we are going to have a lot of very interesting things that are going to be done thanks to those techniques that are just those mathematical techniques that I was talking about. So we shouldn't, make people afraid of it by saying bullshit like this guy is saying, like a French guy whose name Alexandre is talking about as well. I mean, those guys, they are dangerous for humanity, not because there is a risk of lack of funding, but because they are going to make people afraid of this technology that can bring us much more than what it brought us so far. The reality is that artificial intelligence, I mean, the real one, the latest one, my deep learning, to name it, it's only 10 years old. I mean, this one, is really interesting for the next 10 years or for the next 20 years if you look at the era of the internet. So, I mean, leave it alone. I mean, don't say this bullshit when you don't know anything about it. I mean, this guy is very smart. He's a marketing guy. He's very smart at marketing. That's why, he's talking about OpenAI, who found this new algorithm that he cannot publish because it's too dangerous for you. Right? So, shit, show me the algorithm. I'll tell you if it's dangerous for me. But he's a marketing guy. And the other, Alexandre, the French guy, he is a doctor, specialist in wee-wee, right? So it's, I can't talk about him more. But, right.
So this guy is dangerous, but yes, if AI winter is coming, we have a savior. So the Lord's Knights of the watch of AI, we have Dr. Julia. But you were talking about deep learning. So we did debunk popular myth that AI is gonna actually destroy our jobs and destroy our life. But there's a more maybe specific myth that deep learning is so magic that we can't explain the outcomes. And there's this funny tweet that yes, deep learning AI account said yes, if he has the supervision, he can explain the decisions. It's not your mind, it's a deep neural network. So is that true? Is it a myth, or is it actually true that deep learning we can't explain how it happens?
Bullshit as well. So, okay, let me explain that. I'm going to explain something that is actually very difficult to explain. Okay, so as I said, and as we all know, deep learning, machine learning, neural networks, expert systems, all those things, this is just mathematics, logic, and statistics, okay? The issue is that in 1 second, you can do a lot of calculations, right? So it's going to be very difficult to explain a calculation because of the amount of time that you will have to explain it. But this is an algorithm. The algorithm, you are able to explain every single step. And everybody will agree on that, even the guy in the next picture. So everybody is going to agree on that because you can explain every step. If you really take the time, you can do it. But it's unexplainable because there are too many calculations that are done at one time. And for that, I'm going to give you one example that maybe is going to be more graphic. 1914, there is a guy, his name was Gaston Julia, good guy. Gaston Julia was a mathematician, very smart guy, very smart mathematician. And in 1914, he discovered, if you can say that, he discovered the fractals. Fractals, I don't know if you know what it is, but you're going to see that you know what it is in a minute or so. So fractals is basically a mathematical equation that at every single iteration of the calculation, you find the same result of the previous calculation, right? So when I say it like that, it doesn't look very good. I mean, and you don't at all see what I'm talking about, right? Then, in 1955, there was a guy named Mandelbrot. Mandelbrot was a student of Julia at Polytechnic in France. And Mandelbrot was a Hungarian student who decided to move to the States, and he went to IBM. And when he arrived at IBM, in 1955, he had a computer that had some graphical, capabilities. And he did plot in the equation, this equation. And by plotting in the equation, you see, an actual image of the equation. The image of the equation of the fractal, when you look at it, you know exactly what it is. By the way, when he did that, he renamed the equation to Mandelbrot curve, because there was no reason to keep Julia. But anyway, so he renamed the thing to Mandelbrot curve, to Mandelbrot equation. And then, when you see a Mandelbrot or a Julia curve, you understand immediately, because at every single level, you see that little plant-like, thing that it does is actually coming back, and back and back. And the more you look with your glasses, you see that it's the same thing, the same drawing again and again. So I cannot explain it very well, because the best thing is you type, tonight Mandelbrot curve or Julia curve, and you see an image, of course, on the internet on that. And it explains everything very well. What does that mean? It means that, it took 40 years, basically, between, 1914 and 1955 to explain that. Julia was, incapable of explaining it, because he was incapable of plotting it, because you cannot plot this thing, because it's iteration, so you cannot plot it. But on the computer, you could plot it, right? So it was too long to plot by hand. In 1914, there was no computer, but it was, easy to plot in 1955, and then it became totally explainable.
Yeah, so I was also putting this picture because in your book, you even mentioned that Yann Lequin, who is one of the father of the deep learning, who is also a Sorbonne University alumnus. He was doing a lot for his work on deep learning. He's now the chief AI scientist. He also said the same thing as you just mentioned.
Yeah, again, when you do that, when you are not working on this area, you can say a lot of bullshit, right? But when you are working on it, you know exactly what it is. It's just mathematics.
So what is next for AI? So what is the near, but maybe also the far future about AI? How do you see it evolving and advancing?
I don't know. What I know is that, as I said earlier, this is the beginning. This is yet another beginning. The other beginning started with the internet, with the big data, basically. Right? The internet brought us big data. So we are going to do a lot of new advances in a lot of different areas. There are some obvious ones that we can see, from now. In medical fields, everything that is going to be around image recognition, we already see, a lot of advances in the radiology, to find out the breast cancers, for instance, and stuff like that. So obviously there is something. DNA. DNA is a beautiful thing, to apply statistical methods on, right? Because it's a lot of data, and it's a very well-organized statistically data. So we are going to have a lot of very interesting things there. So in the medical field, for sure. In transportation, I was talking about transportation before. Level 4 will be incredible. It's going to save, thousands of lives. It's obvious that it's going to the level 4 cars. They are going to drive much better than we do. Today, my Tesla, it drives much better than I do on the freeway. I let it drive. It's only level 2 or 4 or 3, right? So obviously, there is a lot of advances, more perception, more planning, more things to do in the transportation. So it's going to save a lot of lives.
You even said that you trust more your daughter to be in autonomous car than to drive herself.
Of course, I'm not going to say my daughter, I'm going to say my son this time, just to change a little bit. But my son, I don't want to give him a car. This guy is totally stupid, with his phone all the time, doing texting and things. This is totally crazy. Those guys, when you see that the first reason, of accidents is texting, this is ridiculous. So the car is not texting. Level 4, it's not texting. It's taking care of the car in front of it, and it's going to avoid the accident. It's not going to move on the Place de l'Étoile, but it's another issue, right? So level 4 is going to be incredible. What bothers me in autonomous driving today, what we are talking about it. So not only we say that it's going to be level 5, which is not true, that cannot happen, but also we are talking only today about the 2 or 3 deaths that we had, in the past 3 years. I mean, 3 deaths, right? Think about the number of lives that were actually saved in those 3 years, thanks to Teslas and there are a lot of cars now that have, assisted driving. Thanks to that, we saved a lot of lives. So stop to talk about the 3 deaths. The 3 deaths is accidents. Accidents are still going to happen, of course. There are accidents, but it's going to be much less with this assisted, with this augmented, intelligence than with us only.
And yeah, before we move to the next step, because you explained that even deep learning can actually explain the outcomes, there's also a lot of biases. So can you say a little about the inclusion, maybe this part that maybe AI could be more fair to hire or things like that?
Yeah. So when we talk about AI today, the AI of today, right? Again, we are talking about this big data thing, right? So big data means we choose the data, right? So, and there is a bias in the way we choose the data. And there is a bias in the way we create the algorithm, if we have to create an algorithm in addition to the data. So there is always something that we can do wrong, but it's going to be our fault. This is what I'm saying. It's not the artificial intelligence that's going to decide anything. We decide. So for instance, there is the example of the Thai chatbot back in 2016. The Thai chatbot was basically a Microsoft chatbot that was supposed to promote Microsoft products on Twitter, right? It was a beautiful idea, right? So it was a bot. You talk to it, and you get some interesting things about the products. Great. After 16 hours, Microsoft had to unplug it, to remove it from the public, access on Twitter. Why? 2 reasons. First one, the algorithm. The algorithm that was chosen was basically adding something that is called adaptability. So it was adapting to the public to which it was supposed to talk to. In this case, Twitter. I'm not on Twitter, but most likely you know that on Twitter, after 2 or 3 interactions, you insult the other guy on the other side, right? So the algorithm was very good. It did adapt itself very well, and it did start to insult the other guys on the other side. Okay, so that part was working fine. Good news is that it's a slider, so you can decide to change the adaptability, and so you can fix that. The other issue is a much bigger issue. Microsoft never said that publicly, and they will not, and it's an assumption, but this is something that is very possible. It's the bias of the data. It's very, very complicated to get data, even though the internet is large, there is a lot of data everywhere. It's very complicated to find conversational data that is annotated on the web, right? So you can find some, but it's complicated. So it happens that in the 50s, in the States, there was something that was called switchboard that has been started. And switchboard is basically transcription of conversation over the phone between 2 people, right? And they did transcribe that, and this is a lot of data. And for people who did speech, we were using switchboard all the time, right? So that's a very, very good database. The issue is that in this particular case, because it's a huge database, and to go fast, they decided to train the bot on only a subset of switchboard. And what they took, again, assumption, is the switchboard data from the 50s in the South States. And this thing became the most racist and anti-woman thing in the history of bots. It became basically racist because, of course, in the 50s, in the South States, they were not very, black-friendly, I would say. Okay, so you need to be very, very careful with the data that you are choosing in order to, train your bots, train your algorithms.
So our last topic, before we open to questions, so prepare your questions, is AI and sustainability. It's also some topic you mentioned in the book. So yeah, AI could also contribute to sustainability, to protect the environment, but on the other side, yeah, it could also be damageable.
Yeah, today is actually, we need to start to realize, I was talking earlier, about DeepMind and the fact that it's taking 440 kilowatts an hour. This is ridiculous, just to play Go, right? And those machines, everything that we are doing with the centralization of data, it's going to take a lot of power. Just imagine a data center requires about 60% of the energy just for cooling, just because it's centralized. This is ridiculous, right? So we need to think about those things before we do anything with adding more functionalities and adding more things. We need to think that right now we are going directly in the wall. Because deep learning is great, but deep learning requires a lot of data. And every day we need more and more and more data, okay? And more data means bigger and bigger and bigger centralized servers, right? And we need to think about that. Nobody is talking too much about that today. So that's why, one of the things that I'm trying to push for people to think about two things. Small data. Can we train those models with less data, like we do? I didn't talk to you about the recognition of cats, but when my friend there, Luc Julia, started to want to test his algorithm back in 2007, he had the internet at disposal, right? So he found on the internet, for some reasons, that there were a lot of images of cats, right? Lots of cats, and people were marking, this is my cat. So easy database, right? You have an image of cat, and somebody said it's a cat. So it's annotated, it's perfect. So you have millions of images of cats, on the internet. 2007, very good. So we prove now that deep learning is working because we take a lot of images of cats, we train the model, and we have something that works at about 97%. Great. We proved the system. Very good. But there you ask, but how many cats my daughter needs to recognize a cat forever? Do you know how many? Two cats. 2 cats, and it will recognize cats even at night, even when it's drawn by Picasso. It will recognize cats all the time. This machine not only doesn't recognize all the time, but needs 100,000 images of cats to achieve something similar. Big data, small data, okay? So, it's not very true here, small data, because the reality is that we are talking about multidisciplinarity. We are multidisciplinarity. We are an instance of that. So a cat is not just an image of cat. A cat is something else. It's not going that way, it's going that way. There are a lot of other factors that make us recognize a cat. But anyway, all that to say that we need to go towards small data. This is the first thing. And the other thing is that we need to go also to the edge. So instead of centralizing everything, if we succeed to do a lot of this calculation on the edge, so next to you, next to where you are, then you are going to save right there 60% because of the cooling thing. If you explode the compute, instead of the compute at one spot, you have the compute distributed, you save 60% of energy right there. So we need to think about all those things there, because right now, if we create a machine for every single human activity that we believe is going to be incredible, we go directly in the wall. Imagine today, if 1 million people, if they decide to play Go with the DeepMind machine that I was talking about before, there is not enough energy in the world. Period.
Yeah, you also mentioned in your book that just taking one selfie, it's equivalent to having 3 light bulbs on for 1 hour. So if you want to take a selfie, you destroy your planet.
Yeah, don't take selfies.
and yeah, you also mentioned in your book, and it was very striking that if internet was a country, it won't rank third in terms of energy consumption.
And so we don't have these numbers in mind. We don't realize it yet. But if we start to say it more and more, this is exactly what was happening 20 years ago with the global warming. 20 years ago with global warming, we were saying, okay, bullshit, I don't care, it doesn't impact me. And now it's going to impact you guys. So we feel it, we start to feel it. There is only one guy named Trump that doesn't know what it is. But otherwise, most people believe that it's real now, right? This thing is real as well. We don't get it, but taking selfies all the time, sending emails to 100 people, is a killer. This thing is going to sit on the server, be redistributed all the time. It's a killer. That's not a good idea. So we need to think more, that our actions are, online actions.
You talked about the negative effects, but you also mentioned that in your house, you can also use AI to save energy.
Yeah, so my house, the other thing, so I have, yes, 212 kind of devices, but I'm self-sustained. So it means that, I have electric power, I have a solar system and so on. I don't draw on the external grid. I create all my energy and I actually send energy on the grid. Okay, so because, yes, the system is programmed to please me, and what pleases me is actually to be, mindful about the environment, and so not to have, the light on all the time and stuff like that. I'm married, with an American woman, and Americans, for some reason, they love to leave, the lights on. They love to leave the TV on. I can't take that, right? So, but I'm glad that little by little, the IoT in this case helped me to train, the troop there, and now, actually the light is going off by itself. The TV, when there is nobody, in front of it, turns off automatically. All those things, it saves a lot of energy actually.
Cool, thank you very much. Let's now go to the questions from the audience. Anyone a question for Dr. Julia?
In the current state of art, is it possible for artificial intelligence to read a book? For example, to give a lot of book about, for example, Middle East history. It's possible for a machine to become a specialist of this field?
So, it depends. So there is something today that you might have heard of, that is, it's natural language understanding that we are talking about. So you want to give data, so a book in this case, and you want this artificial intelligence, to become a specialist of what is told about in the book, right? To
summarize all the
to summarize it.
And select topics and
okay.
relations.
So the more features you're going to add, the more difficult it's going to be, right? But if we keep it to a simple feature like, I know a little bit what it is talking about, you can have some what is called feature extraction that is going to extract some feature that is going to know generally what it's talking about. There is something that is called BERT today, a program that is very well known for natural language using deep learning, or Roberta, which is done by Facebook. So those things, they can extract meaning, and classify, to know where in the book it is, and what it's talking about in general terms. So yes, it's possible, but it has nothing to do with you. It's not going to organize the thing like you would do it, right? So it's always possible to imitate something at a certain level, but it's just going to be pale imitation.
Hi, thank you so much for being here. It's super interesting. I was wondering if you could give some insight on how quantum computing could maybe take artificial intelligence to the next level.
Yeah. I like your shirt, by the way. Yes, Samsung. Quantum computing is far away, right? So we are talking about it. We simulate it today. We can simulate, quantum computing. It's going to take a while to have some actual, quantum computers working. We have some samples, but it's bullshit. It's three cores basically. This is ridiculous. So, but it's a very interesting thing to think about. So I always talked about tonight, about mathematics and statistics and logic, right? Because this is what artificial intelligence is today. I never said it will never happen. I always said it will never happen with the current techniques, which are mathematics, statistics, logic. Now, quantum computing is interesting because this is something else. This is not the normal logic. This is not mathematics in terms of pure mathematics. It's more physics than mathematics, right? So there are some assumptions, and as soon as you are in the infinite world, between the 0 and the 1 in this case, when you're in the infinite world there, for mathematicians, it's a little bit, out of this world, right? For the physicists, they love it, right? So quantum computing is the thing for the physicists. And there is definitely something interesting there because you are going to be able to model the world much better with this infinite between 0 and 1 than what we are trying to do with the 0 and 1 today in normal computers. So most likely it's much closer to the world, than the current model that we have. Because the model that we have, again, is just this 0 and 1. And it's just this logic mathematics thing that is, pretty simple. So maybe, but it's going to take a lot of time because it is something that we have a lot of difficulties to understand ourselves. Infinity was always something that we had difficulties with. 0 is also another thing that we have some difficulties with.
One question.
My question is about deep learning. Is there any danger that using deep learning we could influence the society to choose something or influence the society to go to a specific direction? And as an example, I work with machine learning to learn what for example, if a customer buys a specific product, then we recommend that, okay, those who bought this product also bought these 3 products. So now, this influence other people who look at it and say, okay, others bought this, so I'm going to buy it. And this provides more data to back up the idea that more people bought this, versus that was the influencing people that provide us data, not the data.
So, is it the deep learning that is doing that? Or is it me as a manager of the company, whatever it is, that is deciding to use this tool in this particular fashion? This is a question. The deep learning, again, is a tool. I can use it to do whatever I want. So, but if I decide that, I'm going to try to influence people with this tool, I'm going to succeed much better than with another tool that I didn't have before. So this is a very powerful tool, but this is just a tool, and I decide, the human behind the thing decides how to use it. So again, nuclear bomb, nuclear power is very powerful for the good and very powerful for the bad. So, but I decide how to use it.
Hi Luc, thank you so much for your introduction. It was really interesting. And I really appreciate the fact that you are really optimistic about AI. I'm from Europe, I've been living here for 5 years now. And I start to understand this optimism about new technology. Definitely back there, people are freaking out about that. I believe on AI for good, but AI for bad as well. Can you give us a little bit more like the state of AI for bad today, and how do you think people like you that believe on AI for good should act or be careful of?
That's a very good question. So it's not going to happen by itself. Okay, first of all, for sure, when we, and this is why I wrote this book, this is why I'm here, this is why I'm doing all the conferences that I'm giving all the time, we need to be educated. At the end of the day, we the humans, need to be educated, need to understand what it is about, what it is capable of, and the free time that is going to give us when we are talking about robots that are going to give to free us for some jobs, that we don't want to do. This free time, we should use it to educate ourselves even more. We have 2 directions that we as human beings we can take. We can decide to educate ourselves, to do something cool, and to learn more and to be excited about more stuff, to create something even better. Or we can decide to give up. You can just decide to give the keys to those things, and say, okay, it's doing it, I'm done, I'm going on my couch, watching, stupid thing on TV, and eating popcorn and drinking Coca-Cola, right? Great, you can decide to do that. But I'm hoping that by saying what I'm saying is that there is a danger. There is a danger because it's very powerful. So be aware of the danger and fight it, but fight it with what we have, that is much better than those machines. This is this thing. you know, and we can, you know, train it and do even better. We are the only kind on Earth who did progress in terms of technologies. You know, when we are talking about dolphins, you know, that are smart, or when we are talking about ants that are smart, great, they are smart, great for them, you know. What kind of technology did you see in the past 30,000 years in the ants, you know, communities? You see any flying ants somewhere? You see any, you know, ants using some you know, trains, fast trains or something? So nothing. So we can be very good, and we are, you know, going that way. So that's why I'm very optimistic for it. But I'm saying we need to be careful, because I know that we can't just give up. And if we give up, it will go to, and I always recommend this movie that is called Idiocracy. Idiocracy is an incredible movie. It's the worst movie ever, I guess, you know. But the good news is that it's only 1 hour and 5 minutes, right? So it's pretty short. But when you watch this movie, you realize that, you know, we are pretty bad off if we give up. Because we are going, you know, to water our plants with Gatorade, and we are going, you know, to eat chips all the time, you know, and all be obese, you know, on the thing. So it can go wrong. Watch the movie.
Thank you very much, the movie. But just to add a bit, don't you think that thanks to this,
because of this,
a lot of people to giving up or to give up because they, in a way, entertain. I'm not a socialist or whatever. I mean, I think I believe on the right balance, but I think there is this power that people like you, even Elon Musk, that you probably don't really appreciate too much, or at least whatever.
I have a Tesla.
We need people who can really, who are in front of that, who are able to take care of the mass of the population, because we are maybe 1% here.
I totally agree. So that's why, you know, we need to have this message. We need to educate ourselves, and we need to educate the others. So this is what evangelism is about, you know, and this is what we need to do. I mean, this thing actually, you know, the phone. I mean, I'm not supposed to say that because I'm working at Samsung, but I hate those things. I mean, those things are incredible. I mean, this is, you know, always in your way. It's ringing when you don't want it to ring. You know, I mean, this is pretty bad. I'm not talking about the waves, but I mean, it's pretty bad. And I mean, in this room, who knows the phone number of their parents by heart? Okay, 3 of them, right? And we don't need it anymore, thanks to this shit or because of this shit, right? So this is bad, because we basically don't work anymore. I mean, now, you know, when you're looking for the birth date of Napoleon, you don't need to remember it. You go to Wikipedia, to Google, you know, and you have it. So that's a danger, yes. So you need to be excited to go to reach out and to find the birth date of Napoleon, because it's very, very important to know, right? But that's good. So you, I mean, this, you're right, but we need the 1%, like you are saying. We need to educate. We need to evangelize.
Thank you.
Hello. It seems like your vision for the future of AI isn't really in line with what the current state of deep learning, because too many examples, too much compute, and you're saying that maybe the future is more with techniques that require less training data and to have the same accuracy. Do you have any idea, or maybe a best bet on like what new techniques are being developed right now that could potentially be adopted by the industry in the future, or?
It's a research field. So people, you know, there are some people that are looking for small data. There are people that are looking to do this distributed learning thing. So the issue with distributed learning, you know, is that, I mean, it's a great concept. But I mean, by definition, if you have, you know, distributed learning, you don't have the data that is the centralized data, right? So the centralized data, it's where the data is. So there are people working on it, trying, but I mean, today there is not a lot of results there. I mean, there are people that are doing some very interesting research as well around trying to marry the old stuff with the new stuff, right? So what does that mean? I mean, deep learning, yeah, so we know the benefits, I mean, it's interesting and so on, but we shouldn't forget maybe that, you know, for 40 years, expert systems gave us, you know, a lot of very interesting things. So marrying that, and there is a professor in Stanford, for instance, you know, that is trying to do that, remarrying the old technology, the old AI, with the new AI. So this is the way we can do it, but I mean, if we go back to quantum computing, most likely what we need to do, we need to come closer to our brain. So it's very difficult, as I said before, because our brain, we only know, you know, 20 to 40%. But this is biology. You were not, you know, born maybe, but 20 years ago, I mean, it was all about, you know, biotech, you know, and biotech is being, biotech doesn't exist anymore. I mean, the biotech, I'm not talking about pharmacy, but I'm talking about, you know, trying to emulate our brain by emulating the biology of it. So nobody is working on that anymore, or maybe 2 or 3 people somewhere in the world. So we need to find some other techniques. I don't have them. I don't know what they are. I mean, today, like everybody else, unfortunately, I'm using the techniques that are easy to reach, right? Because we have so many things to discover still with those techniques, because those techniques are very practical, you know, to find cancer and stuff like that, like I was saying before. So it's too easy, because it's there. But we should look at this, you know, I'm trying to warn, we should look at something else, but this is part of the education thing, you know, we need to realize it first to look at something else. But today, unfortunately, I don't know a lot of people working on that. I have some of my guys that are looking a little bit at quantum, a little bit at you know, biologic stuff, a little bit at something like small data, you know, and distributed learning. So, but it's, you know, it's really researchy at this point.
Hello. So there's a lot of talks about deepfakes. These days, a lot of fears about that, using AI to create fake videos. According to you, is this going to be an issue, or are these fears completely misplaced?
No, it's an issue. It's definitely an issue because it's very well done, right? I mean, when you look at the video of Obama that is saying that Trump is great, I mean, you can wonder if it's true first. So, I mean, the good thing, it's a good exercise, you know, for your own brain to say, okay, I'm saying that, is it real? So it's good for you. But, I mean, it's an issue because a lot of people are going to fall, you know, to this thing. So we need to be very careful with that. But, I mean, when you think about it, it's easy. And this thing is very, very easy to create, you know, Obama talking to say good stuff about Trump. It's, I mean, any of you can do it in, you know, in a few clicks or in a few hours of programming. So that's an issue, but as I said before, like everything else, you know, it's just us who have the control. If we want to use that, you know, as something bad, you know, this is what propaganda is about. You know, during the Second War, the Nazis, you know, they were using propaganda to have something, and it was false messages. It was already deep fake. Maybe it was just fakes, you know, but it always happened.
Hi, thank you for bringing sustainability to the conversation. My question is, so my understanding is AI deep learning is requiring more and more energy, right? Is it, so I have two questions. One is there a way to drive developers to code in a more sustainable approach, right? And second question, automatically, is there at some point some kind of limitation, like would there be a ceiling at some point that we will not be able to power the internet, or, you know? So
first question is that most likely yes. We are not trained to that today. I mean, we don't even think about it. This is coming back to the previous question about, you know, how to do small data, how to, you know, use algorithms in a better way. So we don't really know, right? So this is research. So there is no way to train the mass of programmers, you know, in that, because we actually don't have really the answer. We can train the people not taking selfies and stuff like that. So that you know, is much easier at this point. Or we can train, you know, people not to use social networks doing something. You know, so I mean, there are things we can do, but you know, it's our own ethics that are going to apply, you know, in this other case. The second question is, yes, of course there is a ceiling. I mean, this is what I was saying, you know, earlier about the Go. If 1 million people are playing Go today, not enough energy, period, right? So there is a ceiling, there is an issue, and this is where we need to realize that, you know, if we create an assistant, for instance, for every single type of things that we're going to do, right? So just imagine when you look at you, I mean, usually I draw a beautiful drawing there, but when you look at our intelligence, right, us, we are basically good at everything. I mean, we are okay at everything, right? So any subject, we have something to say about it, right? I mean, we cannot stop to open our mouth, right? So we can say anything about anything, right? So now, when you look at those anything, it's infinite, the number of subjects. If you create AIs for every single of those subjects, it means that it's infinite AI. This is what people refer to AGI, you know, artificial general intelligence. It would be like us. But this infinite AI, by definition, is infinite. And if it's infinite, you know, we are killing the world right there for just one assistant. Right? So, yes, of course, we need to realize that it's not possible to use the amount of energy that is borrowed from somebody else to do any kind of thing that we want to do centralized in the servers.
I just had a simple question. Last year, or I think a year and a half ago, the first painting that was generated by AI was sold, I think in New York for like a couple $100,000. When you have the context that we have today, and you know that it's just a painting that was generated from a bunch of paintings and examples and just a mathematical approximation of something, like, what's your take on that? How do you react to this?
I react like I just did. Okay, I mean, this years ago, people were saying, "Oh, I got a painting done by a computer like Van Gogh would have done." Yeah, sure. You know why? Because you gave it, you know, every single 132 paintings of Van Gogh, you know, to digest. And then you said, okay, now, you know, I'm going to take this thing, you know, and I'm going to put it there, and it's going to do a deep fake, basically, you know, to do that a la Van Gogh. Okay? Okay. I have a piece of music that was just written by Mozart last night. Yeah. I put every single pieces of Mozart in my computer, and then, you know, I said, okay, play Au clair de la lune, you know, by Mozart. And this is ridiculous. And there is no creativity there. This is zero creativity. This is copying. This is just, you know, imitating. There is no creativity in artificial intelligence. Never. And it will never happen.
Thank you.
One last question?
It's ridiculous, but maybe in 100 years, nobody knows Van Gogh. And see the difference between the race.
This is exactly the issue of
yes,
deepfakes that we're talking about. Yeah, that's true. It looks like a Van Gogh, but most likely, you know, the very good human experts about Van Gogh, they are going to say, oh, it's not a Van Gogh. You know, so there will be somebody who knows. I mean, there are a lot of people who did copy the Van Gogh, you know, in the past 200 years, right? I mean, 100 years. So, you know, it will continue. So if it's a computer doing it, great, be my guest. But I mean, first of all, we know all the paintings of Van Gogh today. Okay, so it allows us to know that if there is somebody that claims it's a Van Gogh when it's a camera like this one, you know, on it, I mean, I'm going to suspect something. Right. So
you know, but kids in the future know.
Unless, you know, we bring the culture, we bring the education, this is our job. Yes. Our job is to bring all this shit, you know, and not to give up with our kids, you know, telling them, okay, go on YouTube and don't bother me, right? Yeah.
Cool. Thank you very much. Alumni, I think we'll find it. You can open it right now.
I can?
Yeah.
It's a book. Do you know it exists? I think you can do it.
I hope you don't mind. So, yeah. Luc Julia's brand is is that every time he's wearing like Hawaiian shirt. So this is a book about the art, history, and culture of Hawaiian shirt.
And what is very important is that what you just said is wrong.
Okay.
So
no, maybe.
It's aloha shirt.
Yeah.
And it's very, very important because when you say a Hawaiian shirt, you show basically that you don't know anything about it. But when you say I'm wearing aloha shirt, now you know you're a specialist.